like instead of at an angle there. This works well.
All right, good morning, everyone. We're gonna go ahead and get started. Isaac, thank you so much for coming to talk a little bit about some of the work you've been doing in the school, as well as, I guess, the impact that it has on us as consumers. Take it away.
Sure, of course. Good morning, everyone. So my name's Isaac. If you don't know me, I'm Pastor Amy's son, and I go to Etown College. I'm a senior. As part of our senior courses, we do something called chemistry seminar. And this is where all of the senior and junior chemistry students are required to do a presentation of some sort, often around either someone's specific research. Like last year, I did a lot looking into PFAS, which is kind of like one of those forever chemicals that's out there. This year, we were looking at hot topics in science, which can be very interesting and a lot of different topics, obviously. So I decided to choose recycling, which isn't normally viewed as a hot topic in science, but as we'll see, there's a lot more of an effect of recycling on the environment than we might think. But yeah, so that's kind of like the history of where this presentation come from. I've taken out some of the chemistry that I originally put in, though I do have some extra slides that can go into some more of the detailed mechanisms if you guys are interested. There's still plenty of science in here, of course, but just less of the OChem 2 level stuff, if that's okay with you all.
Maybe I should sit up here.
That's fine.
I was sitting back there because I'm going to have to leave, but this is a little silly. I'm making
Just
more.
leave it.
Oh, you want to do that? I think it'll be.
Do you want to add and do it all?
I like.
This doesn't have to be super formal, so if you guys have questions like while I'm presenting, feel free to go ahead and either raise your hand or just ask, either way. So a little bit about where we're going today. We're going to talk a little bit about recycling 101, so just thinking about the definition and some of the other topics we'll be looking at. Then we'll be looking at types of recycling. We're going to move to pros and cons of recycling, so thinking about more than just the science, but also the economic impact and some of the other stuff. Then we'll have some reflections and conclusions. And lastly, we can talk about any questions that come up throughout the presentation or questions that you guys just want to talk about as a group after we're done. All of this is about free. So recycling 101. So we'll be just talking about recycling in the definition of processing something into a new form. So not recycling in the terms of reusing, where you might use like a milk jug into a bird feeder or something like that. Well, that's very good. We're really just looking at the process of turning an old material into a new material. So essentially taking something we've used, recycling it into, again, a new material. So a brief history of recycling. The first kind of recorded bit of recycling came from Japan in about 1031. Japan recycled their old paper into new paper. Then there's a bit of a gap. And then in 1897, New York City opened its first materials recovery center. So this looks at mainly metal recycling. And then in World War II, they kind of had a call for recycling for specific materials to other material recovery facilities, and then they were collected and used for other materials for war. Then in 1960, the more modern recycling kind of takes off. This is where they implement collection bins into certain areas and developments and stuff like that. Finally, in 1987, New Jersey is actually the first state to put in a universal mandatory recycling law. Essentially, it's just telling people that you don't have to recycle. I mean, not everyone recycles today, but you have to have the access to recycle. So this kind of catches us up to the current modern day version of recycling, where we have green bins out on the streets. So then we'll be looking at a little bit about metal recycling, and then we'll be mainly focused on plastic. So we'll be looking at the processes of both, but then within plastic, we'll be looking at some of the impacts that plastic recycling has on our environment. Specifically, we'll be looking at PET, which has a much longer, complicated name, but we'll just call it PET. That's the plastic that's in like your water bottles and stuff like that. So within metal recycling is a little less complicated than traditional plastic recycling, as we'll see. There's really only one main way that this gets done. It starts with collecting and sorting. Only about 30% of the metals that are out there are actually being recycled. This then goes through a long, complicated process in order to increase its heat. Yes,
When you say 30%, they all that only because they can be, or because people choose to?
it's more of a choice. There are some metals that are hard to recycle, especially when you look at some of the catalysts and stuff like that. That can be harder to recycle, but this was just looking at more of the junk metal that's out there. About 30% of that is recycled.
So
Yeah.
for the most part, all metal could be recycled in some way.
For the most part, yeah. It just kind of depends on the amount of energy you put into it for the material you get back down. So there's a trade-off there.
And there's no point sometimes.
Sometimes.
You spend more energy than you're getting out.
Exactly. But some of the energy that's put in is to make it easier to process. So the little processing step, essentially they'll squeeze it and make it really thin. They'll shred it, and then that makes it easier to melt. And then they're able to purify it using electrolysis or using a magnet. They can pick up some of the magnetic metals. But that all just purifies it, and they try to make it as much as one metal as possible. They try to do that for plastics as well, but it's a little bit easier for metals. So then looking at the types of plastics that we'll be recycling. So we have high and low density polyethylene. That's some of the stuff you'll find in your plastic bags. Now, a quick note, all of the plastic items about to show has more than one plastic in it. This is just kind of like the standard image I chose for this. So like this plastic bag, the reason why they're so hard to recycle is because they're extremely engineered, and so there's more than one polymer in it. It's meant to be, essentially, it's not meant to just fall apart and degrade, which is some of the issue with plastic recycling. So some of the research that's being done is also into how we can essentially use less materials to build up some of these plastics, or make it better to fall apart, make it more like a Lego set, and less like a sculpture. So anyway, this is high or low density polyethylene, and the higher low density is just amount of branching. It's very technical stuff we don't really need to get into. And this little, my mouse show up here? Yeah. So polymers essentially are just repeating chains of this main thing that I see here. So the little bracketed part is what's being repeated for as long as it needs to be. We'll get into a little bit of kind of like the pros and cons of different recyclings. Is essentially how well are you able to control how much this can be repeated, right? So if you're able to fine tune that and know exactly how long your chain is, that means it has certain properties that are beneficial for what you're trying to make or not beneficial for what you're trying to make. Either way, it's very important that you know how long those repeating chains are.
What's the chain?
So the chain is essentially this segment here. Oh, another one. So this is PVC, often found in piping, polyvinyl chloride. So the chain would be essentially the bracketed region repeated out for however long you want.
But it's a chain of what?
A chain of this monomer. So within the polymer, where there's three different areas, there's a monomer, like dimers, or oligomers, and then there's polymers. So it's how long
The chemical
Yeah.
property?
Yeah. So like, it would be kind of how long we have our repeating unit. And that stretch could be a polymer. And this is a very short polymer. This is not actually qualified as polymer because it's much longer. This would be like 5,000 repeating units. Yeah.
Is there any carbon in there? I think.
There's plenty of carbon. Each one of these is carbon. Sorry. Thank you. It's good. We just draw that up.
And Cl.
Cl is chloride, chlorine. But yeah, so a polymer is essentially just a really big version of this one little stretch, which isn't wildly important because we're not going to get into some of the more complicated mechanism, but that is what the polymer is. The monomer essentially is just one unit of this. So this would be like the monomer of it, which is the goal would be to break it down to just that monomer. So then we can control how much gets built up. So that's kind of the yes.
How do I know if this is plastic, or what should I do with it?
What should you do with it? So we'll get into recycling in Etown a little bit later, like what we can recycle. Unfortunately, a lot of the cups, especially like that, if they're not plastic, they're made to be biodegradable. However, most of those cups are not biodegradable in our backyards. They have to be taken to a very specific facility to degrade. So there's not much we can do with just that cup.
Don, just hold on to it and bring it next week and use it again.
There are some people that do this. Yeah.
Use it the rest of the day.
But that's a mixture of all sorts of different, probably cardboard and plastic or wax or something like that. That can be broken down, but requires very extremely specific processes. So moving on into our recyclable polymer, like what types of polymers we can have, we have polypropylene, which is some of the harder plastics we'll see. Polystyrene, which is the styrofoam cups that you'll often see around. And then finally PET, or polyethylene terephthalate, but we'll just call it PET for my sake and you all's. And this is often what we see in plastic bottles. And we'll be looking at specifically PET when we're thinking about the impact that a plastic bottle has on the environment and how much energy goes into it. So these are kind of our recyclable polymers. There's many other different polymers out there. People are doing chemistry all the time to try to figure out how to recycle polymers. For instance, over the summer, I was looking at a polymer that's actually not on this chart and trying to figure out ways to build it up to make it into a different type of polymer. So there's all sorts of different chemistry being done within this realm. It's very active. Very good. But we're looking into whether or not recycling of it is worth it. Now, thinking about recycling, there are a couple different methods of plastic recycling. We have our primary, secondary, and tertiary. So our primary method of plastic recycling is kind of what's called a closed loop. Here, we are taking a product, we are recycling it into a similar, like the same product. So think about a water bottle, plastic water bottle being recycled into a plastic water bottle. In our secondary method, we're doing a very similar thing to the primary method, but we're taking the material and putting it into a new product. So plastic water bottle to reusable bag, something like that. Our tertiary method is going to be our chemical recycling, which we'll get to when we get to. It's a little bit more complicated than just can say here. So the little chart down here, we can see that within primary and secondary, we're staying at our polymer level, so our big chain. And then in our tertiary, we're able to control the chain. So our primary and secondary similarities, they both rely on mechanical processing and extrusion. And we'll see that in our next, we have a little diagram that kind of shows the flow of plastics through a recycling center. And essentially what we're doing is washing it, remelting it, extruding it, and then forming it into pellets that can be used to produce a new product. The first of this is relatively easy, it's cheap. This is what's seen in a lot of our recycling centers. We're not seeing our chemical recycling as much. So of course, as that science develops, it will eventually grow and ideally overtake some of this primary and secondary recycling. The cons of the primary and secondary is that it's a very sensitive process. We need to be able to sort out the different plastics we're using. And as I mentioned earlier, a lot of our plastic products have multiple different plastics in it. So something like PVC can actually start to degrade your machinery. If you're making chlorine gas, it's not great for you. There's a diminishing quality of our plastic. So because we're not working at a lower level, like on our monomer level, and we're just on the polymer level, we're not able to control essentially how long that chain is. If we're able to control that, then we're going to have very different quality of material on the output than what we might want. There's also a lot of energy that's consumed during this process with all of the heating and washing and moving of the plastics, all of that. Some of the differences, like I said, primary is meant to return to the same kind of form of the plastic, while secondary, we can move it into essentially a new product. Often secondary does take more energy because we're moving it to more universal form that can be used again for different products. So again, here's just kind of, I was just explaining, but in a fun little graphic I found, they separate it and then they are able to wash it and dry it. The separation by floating, that's our washing area. They're able to melt it, re-extrude it, chop it up, the pellets, go on to use it. I was confused why they have to pelletize it if they're already chopping it up. And that's just because that makes it a better, like it's easier to use in the manufacturing process later on. If you're also wondering that. Because if they're already chopping it up, why are they going through that whole extra process? But yeah, anyway. So that's our secondary and primary recycling. And this is what we'll kind of jump back to when we're thinking about some of the pros and cons, because this is what we are seeing at the industry level. But for a second, yeah.
So my experience, plastic typically burns, so they can melt it, And how does that work?
So think of kind of like a 3D printer. So here we're able to set a very specific temperature, and we can extrude some sort of plastic filament through it in order to make it formable but not burn it. So yeah, a lot of plastic will burn, but that's often what happens when we're mixing a lot of the different plastics. So if we're able to sort it and we know what temperature we need to put it at, we can get it to essentially the right temperature to melt it, but not burn it. I'm sure this is not a place you'd want to just walk around with without some sort of mask on, because there's probably a lot of burning plastic, and that smell would be in the air. But they're able to save the plastic by setting that specific point. There's ways that you can calculate the melting point for different plastics, and when you mix plastics, that's not something I know, so I won't go into that. That also might take more time than we have today.
So Isaac, that, at the top there, from trash to cash, are you gonna talk a little bit about the money part of this?
We'll talk about some of the economic benefit of recycling. Yeah. So this is a lot more of the chemistry side of things. We'll move through this part a little bit quicker, but this is just an example of how we can use chemistry to control and break down a polymer and then build it back up. So there's a lot of different ways that you can do chemical recycling. What we'll look at in our very, very short example is glycolysis. This is not the same glycolysis that happens in your body that you learn of in like AP Bio. This is just using ethylene glycol. Glycolysis is able to control the quality of the PET because we're able to break it down to our monomer level and then build it back up. So we have a little bit more control over that, which makes for a better product. It can have some lower costs and energy depending on the different catalysts you use. We're not going into the catalysts that were being used. If you'd like to, I do have a graphic hidden that we can all look at, but it's a little bit complicated. And yeah, it can be produced through chemical pilot. So our very kind of quick explanation here, essentially, if we have our long chain, we can introduce ethylene glycol, which will kick it off. And then we have a terminal end of our polymer. And then we can introduce another bit of ethylene glycol, which will kick off the other side. And then we have our monomer. And BHT is bis-2-hydroxy terephthalate, which again, we'll just call it our monomer.
Yeah, I knew that.
You did? Oh,
Yeah.
okay. I'm sorry. I don't want to repeat information. But this is our monomer. So then, in order to build it back up to whatever size we want, all we do is we take it, and we have the ethylene glycol leave. Like, this is much more complicated than I'm showing it.
It's not this little thing.
It's not just a little thing that floats away. But then we're able to relink the chains to form back our PET. Again, I have a much more complicated graphic. We don't see it. And it's not all going to be able to do this in one process. It's really going to happen over a lot of time. It will slowly break down the chain. It doesn't just break off one section. But that's our chemical recycling. And obviously, like the slide I had before, there's a lot of different methods to do this. They're still figuring out the best method to do this. Again, this is an area of active research. So like what I did over the summer was I actually zapped plastics with electricity to get it to do different things like this. So there's a lot of different ways that we can go about essentially using plastics or polymers.
So you end up with the same thing you started,
Yes, which is the goal.
but it's clean or something?
Yeah, so that's a good way of looking at it. It could be cleaner or it could be exactly what you want. So if you have a chain that's like 10,000 units long, but you only want a chain that's 2,000 units long, you could use this process to break apart the 10,000 unit long chain and build more 2,000. Versus our other method, which would take a 10,000 unit chain, maybe break it a little bit into like 7,000 or 8,000 and not really be what we want.
I'm curious, this summer you were burning things at home?
In my garage, yeah.
I mean, I was interested in the environment.
Yeah. No, I was at the University of Delaware and I was doing research on plastics. And we were doing electrochemistry, which isn't something I knew a lot about until I got there, but essentially it passes a current through a system and I changed the way the plastic behaves.
I feel better.
Thank you for the clarity.
So looking at some of the pros and cons, we'll look at the economic, we'll look at some of the pollution, and we'll look at essentially the impact of the bottles. So within the economic information, this was kind of gotten from the EPA. Roughly about 700,000 jobs revolve around recycling, which is a lot. And metal is the material that most revolves around it. So both thinking about the transportation and the gathering of that, all of that revolves around metal. There's roughly 1.17 jobs for every 1,000 tons of material. So the more that we recycle, the more jobs we might be able to create. Though a lot of this is automated, obviously there's still a lot of facilities and built. And then $37.8 billion goes in salaries to the people that work here. And then we have $5.5 billion of tax revenue that can go on to continue the fund recycling program. I don't know if it's being specifically used for that, but that's not a small amount. It's bigger than I thought it was. But that's kind of like what the economic drive of recycling is. So in order to have like a processy, there, like, especially if you want it to be environmental, there also has to be an economic drive. We can't just do things because it's better for the environment. There has to be some sort of economic benefit. I mean, that would be great. We should do things without an economic benefit, but on a larger scale, that's just not how things work. Now, another pro is that there's just less plastic in the landfill. And so here, one of the different breakdowns, if you remember earlier, we said about 30% of metals are recycled. Only 9% of plastics are going through a recycling process. And then most of them are ending up in landfills. Some of them are being incinerated and can be some energy that's produced by that. But that also produces a lot of bad stuff if we're burning plastics. So only about 9% are recycled. When it's in a landfill, landfills can produce something called landfill gas, something I learned about in my environmental engineering class this semester, which isn't great for anyone. It's mostly made of different methanes and CO2. There's ways that some people, if you engineer it correctly, you might be able to capture some of it and go on and use it. However, there was a site in New York, whatever, that was causing respiratory issues for a population that was living near a landfill. So this stuff isn't, like, you shouldn't really be breathing a lot of methane and CO2. That's why it's not one of our main components of our atmosphere. Well, it's turning into one of our main components, but it shouldn't be. We can also have leaching of our landfill into the groundwater, which is also not good, as it can affect the water that you're getting at your house. So again, one of the pros of recycling is that there's less trash. There's some economic benefit from this. But thinking about the cons of recycling, and this is kind of what made it a hot topic, is thinking about microplastics. This was one of the first things that I thought about. Microplastics have become a bit of another whole other hot topic amongst themselves, because we kind of discovered that they're hanging around. But a little bit about microplastics, if you're not sure what they are. They can be generated through primary and secondary recycling. They are particles that are very, very small, and they're particles of plastics. They're found in wastewater, they're found in air pollution. We'll only be looking at a wastewater scenario, but they are found in both. They're found in your food through different bioaccumulation and aggregation, which we'll talk about in our next slide. They can be all sorts of different polymers we talked about earlier, and stuff we didn't talk about. They can really be a lot of different plastics, which is not great. The average adult will eat a lot of microplastics per year, and that equates to like 5 grams per week, which is not ideal for anyone.
On WITF this morning, they had a whole segment on
Really?
this. Microplastics are found on the top of Mount Everest.
Mm-hmm. They get in the air.
Do those numbers include microfibers?
I'm not sure. That's a great question. That's also an issue, mostly within the seas. There was a presentation I heard over the summer. She was looking at, there was a girl that was researching textiles and looking at essentially microfibers in the ocean in ways that they will be able to break down. I'm not sure if these numbers include that, though. That's a great question. But yeah, so that's kind of the microplastics issue. It's not great. And if we're thinking about what we're doing during primary and secondary recycling with the washing and the cutting and extruding and the air pollution and the water pollution, we can see how that might be an issue. So we see that within a specific materials recovery facility, this is actually a study that's done in the European Union, because there's not a lot of studies done like this in the United States for some reason. The concentration range from about 2.5 times 10 to the 5 microparticles per meter cubed of water. That's what the units are there. So about 1 times 10 to the 9 microparticles. So for context, this would be 1 times 10 to the 4 microplastics. So it would be the low end, really low end of what's being extruded out. Now, they did talk about how there was filtering and all of that, and this is the numbers post-filtration. So they did try all that they could to remove the microplastics, but when they are very, very small, You saw that there's 1 to 10 micrometers. There's not, again, it's the trade-off between investing all this energy into purifying the water versus just releasing it. Now, when it drains directly to the environment, this is where we have our bioaccumulation and biomagnification. So we are more in the magnification side than accumulation because we are on a very high trophic level. So, I mean, and there's also bioaccumulation. Bioaccumulation looks at one organism throughout time, how much it is eating of a certain pollutant. So in this case, we can think of it as microplastics. So one fish throughout its time, how much microplastics it's eating versus biomagnifications, like if the fish is being eaten by a bigger fish, and then that bigger fish is getting eaten by a bigger fish. The bigger fish has more microplastics in it because its food source has more microplastics in it. So that's where we have the micro or the biomagnification. And so then us eating the fish or other animals that are eating essentially these microplastics, we have the most amount of the biomagnification or that higher level, which is not great. So that's why it's a big issue around us. And then another we're going to be looking at like a life cycle analysis. This is kind of a complicated diagram. I'm going to try to break it down as much as possible. But basically, just a couple of things before we look at the chart. Our definition here of recycled bottles is essentially bottles that were used once, recycled, used again, and then dumped into a waste facility. We'll also be looking.
Recycle isn't still being used as the original bottle.
Correct. Correct. So we'll look at the chart here for a second. We'll be looking at this area, which is looking at essentially a non-recycled bottle and a recycled bottle. And so in order to have a good recycled product in this study, they use non-recycled polymer to build up some of the bottle. So you'll see some of the numbers are kind of inflated because of that, and I'll point it out as we see it. Then all data is cradle to grave, so essentially from when it's first produced to the transportation to the consumer to where it's essentially then in the waste. So this isn't necessarily just from production, I'm trying to say here. So this is the amount of energy it takes essentially to produce and use and all of them for one bottle. So here, can everyone see that okay? I have a bigger graphic, if not. Yeah, okay. Use your glasses. So essentially here, we can see that for a petrochemical PET bottle, so this is one that is essentially not recycled. This is the new plastic. It takes about 75 to almost 90 megajoules to produce a kilogram of bottle substance. And so I kind of broke that down based off of the average weight of bottles, blah, 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 blah. So it's about 0.9 megajoules per bottle made with new plastic. So that's how much energy goes into creating one bottle. On average, a house will use about 107 megajoules a day. And so that's essentially to produce 1 kilogram of bottle material, it's the amount of energy a house uses a day. So I don't know if that looks worse on the bottle or the house. But either way, that's a lot of energy. And then when we look at our recycled bottle, again, we can see that our recycled bottle is our triangles over here. We can see that it's still very high, and this is because, again, they have to use the non-recycled polymer when they're doing some of these calculations, so that artificially inflates it to be higher than it needs to be. But that's hanging around 70 megajoules and about 0.68 megajoules per recycled bottle. So not that much less. I was expecting it to be better, I'm going to be totally honest. We'll see in the next carbon one, it's even worse, but yeah. So that's how much energy. So then looking at the amount of carbon, so these numbers are in CO2 equivalents. What that basically means is that there's a lot that's emitted from factories, there's a lot that's emitted from cars and trucks and stuff like that. So they equivalent it in CO2. So they normalize every pollutant that's produced in terms of carbon dioxide. So methane has a certain amount of effect on the environment, and they have a ratio to transform the amount of methane into the amount of CO2 that's produced. So that's what they mean by CO2 equivalents. And so here we see that the petrochemical PET bottles, again, the new ones are almost in line with our recycled bottles. And again, we kind of I did the average range when we're looking at how much one bottle emits. But we can see that it emits a lot. So per kilogram of bottle that's being made, we have about 5.56 kilograms of CO2 emitted. And then for the recycled bottle, we have about 4.5 or so, 5 kilograms of CO2 emitted. So that's about 60 grams of carbon or CO2, sorry, for a new bottle, and only 50 grams of CO2 that's being emitted into our atmosphere for a recycled bottle. For reference, again, 1 gallon of gasoline, so just driving around, emits about 9 kilograms of CO2. So if you want to do the math, how many bottles you might use throughout a week or a day, that's equivalent to gallons of gasoline, which is not, that's a lot more carbon than I was expecting to see per bottle. So I try to use more of my recycled bottle. This is coffee. This is not one. But sometimes it's fun. So yeah, both of these we're just looking essentially at overall what one bottle does to the environment and what one bottle looks like. And so kind of the general takeaways from this that I had was that there's many different ways that we can recycle. We see a lot of primary and secondary out there, and we see the pollution that it can cause. Within the tertiary and the chemical, this is exciting stuff that they're developing, but it's not done yet. We don't have a lot of industrial scale applications of this. There's both pros and cons to recycling plastics. Most of the cons are related to our primary and secondary. That's not to say there aren't cons with the tertiary. It's just that I haven't fully gone into what the waste looks like for that. But there are a lot of known cons of the primary and secondary recycling methods. So at the end of the day, it kind of leaves you with the question of, should we be recycling more? Should we be recycling less? Really, what should we? And so I kind of landed on, it's better to follow the first two principles of reduce and reuse, and leave recycling as our last ditch. I feel like it's not normally explained that way. I feel like a lot of the consumer world is like, you can buy it and then just recycle it and it's totally fine. But as we saw, especially think about plastic water bottles. That's something that was like, I mean, back when I was younger, we used to have a case of plastic water bottles just sitting in our car, or if we needed them when we were out soccer practice, stuff like that. And that's good. But like the amount of carbon that all of those had a very cumulative effect. And it was just the mindset you could recycle it and you'd be done with it and it's okay. But that's really not the case. It's polluting the environment more than we really know. That's sad. To end on a more positive note, kind of what we can recycle in Etown. I just looked this up kind of quickly. This is from the borough website. The reference is undisclosed here. But essentially all that can be recycled. They have a one-stream recycling area. You can do corrugated cardboard. So this is stuff like packaging boxes, stuff like that. Unfortunately, it's not like the cup that you have in front of you. We can do plastic bottles and jugs with necks, and then metal cans and glass jars. They can all go into the same recycling bin, and you're able to, and then they'll recycle them and take them onto the facility and sort them out and do what they need to do with them. But yeah. So that's about all that I have for you all today. Are there any questions? I saw 4 hands go up. So whoever would like to speak first, feel free.
Hey, just a quick question. I grew up in Massachusetts. You know, we had, we would bring our plastic bottles down to the corner store and get 10 cents to turn them in. So that helped with a lot of the problems. And I don't know if they're still doing that. What?
Plastic or glass?
No, plastic.
Plastic.
No, plastic only. So, you know, like Coke cans. No, actually, it was metal cans too, Marty. Yeah. So we would take them to the corner store and get 10 cents, and that's major source of income for me as a little guy, and that in my paper route. And I just remember that. So I don't know if it's still going, but I think that helped with trash and stuff like that. Because when we went to live in the Caribbean, we used to see all the trash. When we lived in the tropics, all the trash was thrown in the ocean. You know, all these beautiful places we lived, and it was all this trash down in the ocean, the Caribbean, or over in Vietnam. We saw it too, but they throw it on the street. They come by every night and sweep it up. So they're doing different ways to accommodate it. But you were going back to recycling started when? What, the 60s?
First recorded thing was paper recycling a very long time ago.
Oh, that was Japan, but no, like the metal in America. The 60s?
Yeah, 1897 was when the materials facilities
Just a thought, my career, I worked for, company in Cincinnati. And the guy he was a 100-year-old building company. And the grandson came out of college, an engineer, and he didn't know what to do himself. And the, metal recycling was catching on. And they didn't know what to do with everything after the war, all the metals. And, he came up with the first steel insulated door in our industry, invented it. And then it was a hard sell because everybody liked wood doors up in England. And then eventually caught on, and then now every house has an insulated door of some kind of front door. Or, the outside doors, including insulated windows. So that came a long time and coming through the 60s, and that he invented the first product. I mean, that's where it came from, was recycling after the war.
Yeah.
Fascinating.
Yeah.
So help me understand what to do with plastic bags. I go into Giant and they give me 5 or 6 plastic bags to carry stuff home in. What should I do?
So that's where, again, I tend to, focus on the reduce and reuse. So thinking about bringing your own either cloth bags, or something like that you can use throughout that process. Or if you're just getting something small, I've had a lot of times where I'll go through self-checkout and then just not grab a bag. Or if I'm going with a person, I'll just ask them not to bag it.
Or
People have-
sometimes I forget to take my bags to the store, then I'll take my card out to the car, put things in the car and take the card back in.
Yeah, that's a great way to limit the amount of bags that you are grabbing. If you are grabbing bags though, there's a couple different ways that you can reuse them. They also do have some bag recycling right inside Giant, but I didn't really go into that. I'm sure it has very similar effects to the environment as what we saw. But you can reuse them as different trash bags. I've used it like trash bags for my garbage can in my room, or if you have animals, it's a great way to clean up after them, or other things like that. But I guess the primary way is just figuring out a way maybe not to use them, or maybe ask them not to bag it like that.
Well, a lot of countries are banning them now.
Yeah.
New Jersey,
In Europe.
you can't have plastic.
Oh, New Jersey, yeah.
Yeah. So there's a lot of people going to paper bags, like 5 cents per paper bag, stuff like that. But yeah.
There's a place in New York that takes all plastic, and reuses it for cement or something like that. Do you know anything about that?
Emma, do you wanna?
Yeah, I'm from New York. So my family, we have like 3 different bins in our garage from the plastics that our township, I guess, doesn't like widely recycle, I guess, is the right word to use. And then we just fill up a big bin, and then maybe like once every few months, we take them to that facility. And I think they pay like $1 or something to do it or something.
You gotta pay to drop it off.
To drop it off.
But there's other locations where you don't pay, just dump it in there.
Correct. And the paying is just to keep them in business essentially, so we're okay paying the $1 or $2 that we have to, but yes, it turns into concrete, which is really great. Then it gets it out of our house quickly, and yeah, there's a lot of different facilities like that take stuff that your area does not recycle.
Yeah. And there's another facility as well that's actually started to mine landfills, to extract materials for electronics. So specifically looking at like gold, and stuff like that. I just read an article about that, where they're doing something like essentially just trying to find usefulness for the trash, put into cement or take out the valuable parts of it.
Can you tell us, I think, more about the textiles? Like I'm finding more and more clothes made from recycled bottles. One thing I do know is you do not put that in the dryer. If you want to ruin it, put it in the dryer. But, it's new to me.
Yeah.
I've only got 3 pieces at this point.
Yeah, I can't say I know a whole lot about it. I do know that, so the graph we were looking at earlier, did have textile stuff in it. I just took it out, for the simplicity of making sure people kind of looked at whatever.
I noticed that it seems to be coming from China.
And
Yeah.
it's on the label, that's how you can tell.
Yeah. Yeah, I don't know too much about it as others in this
Sometimes
room
no.
do.
Sometimes no.
Yeah, feel free to add, but it does seem to overall have a less impact. So here, the squares that we see, these are fibers that are being either recycled, or again, the new fibers. So we can see compared to bottles, they're having less of impact within CO2. And just in general, they have less impact. over time and when being recycled. So I don't know if that really shares a whole lot of what you're looking for. I don't know a whole lot about the fibers.
I just wanted to know if you knew about it or not.
Yeah, no.
That's your
unfortunately I
next
don't.
project.
That's my next one. Okay, I'll report back. I'll hand it back real quick and I'll get to that.
Yeah, when, years ago when we were youth leaders, I was researching ways, fundraisers for young people, of things to collect. And there's a website of places where you could put in a request for a certain item. And if you won the request, you could do this as a fundraiser. And one of the things that caught my eye was toothbrushes. Collect toothbrushes, and then you would get paid for toothbrushes collected. And I was wondering, those toothbrushes, were they going into programs like yours for people to experiment on?
Could be. One of my mentor, was researching this, and this is a little bit gross, but he was researching how diapers could be recycled into toothpaste.
I don't want to hear it.
Yeah, so we'll stop there. But essentially, there are different research groups that could be looking essentially at used toothbrushes or new toothbrushes going into new products. And so that's kind of the way of thinking about that secondary form of recycling, where we're transforming it into a new
Right, but that would mostly be used for research, right? Not actually directly recycled.
It would be useful research until we could have a process that could be directly recycled.
Okay.
Yeah.
Could you tell us what type of toothpaste that is that we could?
So it works, but there's no on-brand toothpaste right now.
It's the
We're
kind,
not.
it's the kind that makes your teeth really white.
There's about 3 hands up. Never. Oh
Yeah,
yeah, Bob, and then we'll.
I
go
just
back.
had thought, I grew up in Boston and there was a mill up in Lowell, Mass, and it was recycled into manufacturing. And the guy came up with recycling bottles, plastic bottles, and made it into ski wear. Originally started with like Etown, Canada, but then I can't think of what the name of the company was famous. And he started that and had built this huge company building, ski wear and down vests and all that stuff from recycled plastic bottles. And I don't know if that led into Kevlar and some of the other stuff, that like sails and, bulletproof vests and all that stuff. But because there was a Kevlar factory up in Scranton that built stuff. This is in my travels. I ran into all this stuff.
Yeah.
But do you know anything about that or
I don't know much about
plastic
the
bottles
fibers.
into ski wear?
Yeah, I don't know too much about the essentially plastic into clothing.
Okay.
But that sounds like an interesting topic for people, so I can look into it a little bit. We'll go in back and I'll come up there.
There are trains that go through this area
Hmm.
that have solid waste, I think. It comes out of New Jersey and New York.
Mm-hmm.
Do you know where it's headed? What landfills and so forth?
Not necessarily. Yeah, I don't really know specifically where it's headed. For like if it's headed to a specific recovery facility or something like that, but it's
Right,
probably some
right.
big facility that's working on different material recovery.
I mean, you can identify a train that has solid waste like that.
By more ways than one, I'm sure.
Yeah, cars are unique
Yeah.
in structure and so forth. Okay, thank you.
I think the psychology of recycling is a really important piece to this. Having grown up in a time when it was kind of like reduce, reuse, recycle, Captain Planet and all sorts of stuff that was like, you need to recycle all the time. To find out later that a lot of that recycling mentality and kind of the concept of it, a lot of it was financed by petrochemical companies so for their own products to be recycled and used and things like that. But it seems as if I want to say my generation was kind of lied to about some of the prospects of recycling. And it has led to now, I think what a lot of people do is like wish cycling. I don't know if you've ever heard that term, where it's basically just throw things in your recycling bin because you like hope that someone will, like, I'm not gonna throw this in the trash, I'll just throw this in the recycling bin. And our psychology is that, oh, that makes us feel good. It makes us feel like we're recycling, we're doing the green thing. But that can cause some real issues in the supply chain of recycling companies and sorting and all sorts of stuff. But I think it's really interesting that what I had always understood as this really green and helpful thing is a lot more complicated. And there's a lot more players. Wasn't like Greenpeace was the one who's decided that recycling is what we should do. A lot of it was corporations, so that their products, they were producing a ton of waste and still do, but kind of making the populace feel better about reusing things like water bottles, which isn't real. If you're a water company, you're really a plastic company, because your product isn't, water is pretty ubiquitous, and sure, maybe you get it from this great spring or whatever, but what you're selling is the capacity to carry it around and the ease of use and things like that. So if you're a water bottle company, you're really a container company. You're not really selling, your product isn't water. Your product is the capacity to carry water around easily. And so I think it's gonna continue to be an issue for generations to come, until we can figure out ways to break these things down. And that was a comment. My question for you is is the polymer chains. If things are broken down to, like, monomers themselves are not problematic, aren't like they're synthesized in the environment, because like a microplastic is a polymer. It's like a bunch of, but if you were able to break it down into just monomers, is that still, is that okay? Is that is a ton of like individual monomers problematic, or is it really the fact that they're chained together as polymers that are really the issue?
Yeah, so small organic molecules aren't like fantastic for you to ingest and to process. It would be easier for you to, I guess. But we were talking about this last night, where we were talking about essentially like, why is there bioapplication if we're able to just like essentially get rid of it in some way? Well, if it's a small molecule, that might be easier. I don't really know the biology of that. I'm in biochemistry, but we were talking about processing plastics. Yeah. I think that a lot of the plastic monomers also are very, they have pi bonds to them. That's what allows them to react. And so if they're sitting out in nature like that, they could be reactive with other things and create other problems that we don't know about. I don't know if people really tried to break it down to monomers, just release that and see what happens. Probably wouldn't recommend it. Yeah, do more.
I wouldn't recommend it either.
Yeah.
Most of those monomers are highly carcinogenic. Take vinyl chloride, for example.
Yeah.
But for our bodies and the environment, is it better for plastics to be broken down at that most, direct level, or
no?
It's better if they're in like polymer chains?
So if it's at that lower level, it might be reactive within your body versus just kind of traveling through, and your body tries to break it down, but ultimately can't really.
So it's not as if like even microplastics are better for the environment if they're broken down even more.
Correct.
So we just need to stop them.
There you go.
Two questions. One is the cost to produce a plastic bag versus the cost to produce a paper bag. Is that an issue? And are they making plastic out of things other than oil, like cornstarch or stuff like that? Is that a factor?
Yeah, so we'll talk about the first one a little bit. Thinking about if we're switching from plastic to paper, that sounds like a great idea, but that also opens up a whole host of other issues. So there is a consumer cost if you choose paper at some locations where you might have to pay like 5 cents per paper bag. I don't know if that's to offset production costs or simply just to make money off of people that want to be environmentally conscious. I'm not really sure about that, but even within the facilities that are producing paper bags, you have to consider all of these things still. So it may not actually be that much better. Are there questions there? Okay, cool.
Comment.
Oh, okay. And then as far as the other plastics, alternative plastics, bioplastics, there's actually a table on the back that has a lot of products from alternative plastics. Is that what?
At some point, I'd like to say something
About that? Yeah, okay. Why don't I do this and then we'll switch to thinking about alternative plastics and bioplastics. I was following a company that extracts plastics from the Great Pacific Ocean garbage patch, as well as is extracting plastic from rivers before it flows into the ocean. Yeah, that was there was a big size plastic waste, essentially island, out in the Pacific. Was it the size of Texas at one point? I don't know if it's still the size of Texas, but I have seen stuff on my Instagram reels of people trying to clean that up and processing that in some sort. But that is ocean plastics is where a lot of the microplastics start, which is why we saw the bioaccumulation as a fish. where we're getting a lot of our plastics from. But yeah, do you want to talk a little bit about alternative plastics, or any more questions about kind of the presentation? Oh, sorry, guys.
It's not really a question. It's just a reaction. It sounds like no matter what we do, there's something bad going to happen. And maybe that's how life is, that there's always a downside and you choose the lesser of two evils or whatever. It's not very uplifting of a thought, but it still feels a little bit good. Jason was talking about feeling good to at least do what little bit we think we can.
Mhm.
So
yeah, I mean, we live in such a complex world. There's a TV show and a podcast, and a guy, his name is like Adam Conover, something like that. Adam Ruins Everything. I'm looking at you because I thought you watched that, one of my family members. Anyway, he explained essentially the complexity of like a banana and the amount of oil and petroleum that goes into getting a banana to your household.
Again, I don't want to hear this.
Okay, then we can just ignore that. But there is something to be said about the choices we live, and those choices have been made for us. It's not necessarily choices that we're implicitly making. You might think that we're shopping local by eating fresh produce and stuff like that, but it's really hard to know where that produce comes. So that's where you have to really dive into looking at different community gardens and stuff like that to reduce the toll of what our healthier choices may be. And it's not really our fault as the consumer, but we can do something as the consumer. The choices have been made, but we can make more dark choices about it. Yeah.
Hey, just a quick comment. We were up in Martha's Vineyard this summer and running around one day, and I noticed that there's no bags allowed there, plastic bags.
Mhm.
And I don't know if they have a landfill. I don't know what their recycling program is. But I went to get a glass of water, a plastic bottle of water, and they're illegal. So I went to a vending machine and water only comes in cans, like a can of beer.
Mhm.
So that's a new one.
Yeah. There's a couple of those around here now, actually.
Never heard that.
There's one that looks like an energy drink. It's called like Liquid Death, but it's just water. If you're scared by that, it's just water.
Okay.
Isaac, in your personal life, what's the most important thing you do to preserve the environment or enhance the environment?
Yeah.
I'm making it sort of personal, but just curious what matters to you in enhancing the environment.
Yeah. So, I mean, as a family, my dad's been really good at essentially trying to get us off single-use plastics. So over the summer, I had a lot of containers and stuff like that I was able to use for my lunches. So like traditional like lunch bags or something like that, I had reusable plastic bags. I like to use. It's not great that it's plastic. I probably could have picked a different material that might have had a lower impact. But the biggest thing that we try to do as family and me personally is eliminate single-use plastics from that. But there's other things that I could be doing, like limiting the amount of technology that I'm integrating in my life, because that all has more complicated costs than plastics have. But like I try to use metal water bottles or containers like that for when I'm drinking water or coffee, and just eliminating a lot of the single-use waste items to both reduce just trash in general, but also environmental toll that it has. Yeah. Ralph talked a little bit with me about some alternative plastic stuff. So I think he wanted to share what the back table has. Go ahead.
When Joyce and I looked and saw that you were going to do a presentation this morning on this topic, that really got our juices going, because we've been working at this for a long time, especially Joyce.
Mm-hmm.
And by the way, we recycle all our newspapers.
Mm-hmm.
There's a farmer down below Sonic Village on Bainbridge Road.
Mm-hmm.
We want newspapers. We take all our newspapers there. Otherwise, they go to a landfill or whatever, or we use them in the garden, mulch. And that's easy. And we always take bags to wherever. Got bags in our car, we got bags in our garage, we got bags everywhere. We just pick a bag and take it. Bring it
Paper
home.
bags, or what kind of bags?
Well, there are cloth bags. You can buy them at the store for a little bit and reuse them. They're insulated bags. I've got a bag back there that I brought stuff with. And, anyway, Joyce, and so, you see, to be socially responsible, we have the privilege of having the money to do it. I mean, we pay a little more for everything, but our conscience is clear. And Joyce subscribes to a lot of stuff on Thrive. And there's downsides and upsides, but everything is earth friendly. I got a whole table full of stuff back there. So whether we're in the laundry, there's no plastic or minimal plastic because we got laundry soap that comes in paper form or flat form or whatever. And Joyce, haven't gotten there yet. She uses tablets or toothpaste. And there's a can of those back there. And deodorant can come in a, non-plastic container. Soaps we use, as I said, in the laundry. They're just a multitude of things and they're all back there. And we went downtown yesterday to shop on, local Friday, Saturday. And there's a shop downtown in the square that does fair trade stuff. And that's where she gets her soaps, lotions and things, and it's all natural stuff. There's a lot out there.
Yeah.
In fact, there's a website, and it's on a sheet back there, that you can go online and you can find out, because some stuff that's recyclable and earth friendly isn't so much. So you got to be careful. So this tests everything. Some things don't work. I mean, she's given up on stuff that doesn't work. Well, it's got to work. So that website will test everything. And and styrofoam. There's a place in Lancaster that takes styrofoam. We save it, and when we're going that way to the Longwood Garden, we drop it all off, and they use it.
Yeah, and styrofoam is a very active part of chemical research.
Yeah.
My roommate over the summer was working on essentially how to recycle styrofoam.
Yeah.
And again, complicated chemistry ways to attach different things to it.
I don't know what they do with it, but
Yeah, probably not that. Probably not
we
that.
trust them to take care of it.
Yeah.
We're at time.
Yeah, so I think it's 10:15. If anyone else wants to talk about it, I'll stay up here for a little bit. If not, feel free to check out the back table. And thank you all for coming today.
Thank you.
Yeah.
Isaac, most of that stuff was over my head.
I'm sorry.
What do you think?